In this section, we want to discuss the normal distribution, some of its properties and characteristics, and then look at how we can calculate probabilities with this distribution. We'll start off by talking about the standard normal distribution, which we can abbreviate as n parentheses 0, comma 1, close parentheses. We use this notation as a shorthand for normal distributions, where the first value is represented, the first value represents the mean of the distribution, and as the general notation, we use the Greek letter mu. And the second value uses the Greek letter sigma, and represents the standard deviation of the distribution. So if we're starting off with the standard normal distribution, we have a mean of 0 and a standard deviation of 1. The standard deviation is always a unimodal. So we have a single mound versus multiple peaks occurring, and symmetric distribution. More specifically, it's always symmetric about the mean of the distribution, so in this case 0. And then we can use the standard deviation to count distances out from the mean or count deviations out from the mean. In this case, with a standard deviation of 1, we could count out 1 standard deviation from the mean, 2 standard deviations from the mean, 3 standard deviations from the mean, and so on. It's also important to note that even though it's hard to grasp with a graph or a picture like this, this curve continues indefinitely in both directions without ever hitting the x-axis. So no matter how far above or below the mean we're considering values, if we considered a value all the way at, say, 300, 10,000, negative 40,000, that curve still isn't hitting the x-axis. And since our distribution, the normal distribution, is symmetric, that means that the area under the curve, which continues stretching down to negative infinity, to the left of the mean, represents 50% of all the data values, and the area to the right above the mean and off to positive infinity represents the other 50%.